So we are looking at chapter 10 of class 11 straight lines. We'll talk about the general equation of a line. We have already seen that the general equation of first degree in two variables is something like this. Ax plus by plus c is equal to 0. These a and b and c, these are real constants. And one more thing, that they are not 0 simultaneously. So the graph of this equation is actually a straight line. It will be a straight line. So equation of this form, where this a and b, they are not 0 simultaneously. These are called the general linear equations, or we can also say it to be a general equation of a line. So there are different forms of this ax plus by plus c equal to 0, and the general equation of a line, we can reduce it in various form. First is your slope-intercept form. So if say b is not equal to 0, then what you are going to do, take all except c, this b here, means keep y and take everything on the right side, and just see that the values which this becomes, compare it with y is equal to mx plus c, slope-intercept form. So we see here that the m is minus a by b and c is minus c by b. So m is this, c is this. So we are aware now that the slope will be like this and y-intercept will be like this. But in case if b equal to 0, x will become minus c by a. That will be a what? Vertical line. And you know that the vertical line, the slope is not defined. Is not defined. Then we will take the intercept form. Just consider that c is not equal to 0. And this can be written like this. I'll just show you how we can write this. This can be written as ax plus by equal to minus c, right? Now divide both sides by minus c. Minus c, minus c. We get 1 here and take a here. So it will be like this. So this will be x by minus c by a, y by minus c by b. This is nothing but equivalent to x by a plus y by b. A is the x-intercept, which is minus c by a. B is the y-intercept, which is minus c by b. So now we have x-intercept and y-intercept, but one thing we need to know, that if c is equal to 0, then this can be written, because c is 0, that means ax plus by equal to 0, right? Which is line actually passing through the origin. When we do not have any constant, that means the line is passing through the origin. Let us take the normal form. Normal form, x cos omega plus y sin omega is equal to p is the normal form. Let us equate this with ax plus by plus c. Take c here, minus c. And now just just because these are similar, so a by this a by cos omega, because we are taking the ratio of the coefficients, b by sin omega is equal to minus c by p, this one. So in this case we get cos omega and sin omega. You can get easily cos omega using this and sin omega using this, but we can apply one equation like cos square omega plus sin square omega. This is equal to 1. So these two square is equal to 1. In this case, by using this we can get p directly. So p is c square by a square plus b square. P is like this. So now putting it here again, this one and this one, we can get the values of cos omega and sin omega, and these are plus minus. And you will see that the normal form of these, where cos omega is this, sin omega is this, and p is this. Okay, but p, this sign, proper choice of sign need to be seen, because p should be positive because it is a distance. Let us take this example. This is an equation. You need to find out the slope and x and y intercept, right? Let us take the first one. 3x minus 4y plus 10 equal to 0. Now just write it in the form of y is equal to mx plus c, like this form. So y is equal to mx plus c. M is what? 3 by 4. C is 5 by 2, right? Now x and y intercept, let us write it in the form of x by a plus y by b equal to 1. So here take c this side, that is minus 10. Then divide both sides by minus 10. and take 3 in the denominator and 4 also in denominator. This is A, this is your B. This is how we find out the x-intercept and y-intercept. Now we have to reduce this equation into normal form, and we have to also find out the value of P and omega. So what do? We take this is our A, this is our B. Just square these two and add. Root 3 square plus 1 square and add, and then take the square root. So that will be 2. That will be your 2. So ultimately what you got? This is root 3 by 2. This is 1 by 2. This is 4. This is root 3 by 2, half and 4. Because here what you are doing is you are dividing this everything by 2. Dividing this by 2. And here you get cos omega. This is basically cos 30, sin 30. So these value represent x cos omega plus y sin omega is equal to P. So here you can directly find out this is your omega, this is your P. Now you have to find the angle between these two. How to find the angle? See, if these there are lines, if you need to find out the angle, so you have to see that how they are going to intersect with the axis. So these are line, and the slope of first line is root 3. The slope of second line is 1 by root 3. We have written it in the form of y is equal to mx plus c. Now the angle between two lines is nothing but tan theta is equal to m1 or m1 minus m2 or m2 minus n1 by 1 plus m1 m2. Just place the value. We see the value is 1 by root 3. But we also see the value can be minus 1 by root 3 also, because this is mod. So one time you get the angle as 30, means if this is 30, you get the other angle as 150 degree. 180 minus 30. So these are two angles. Okay. This is example 16. Show that these two lines, these are parallel if this holds, perpendicular if this holds. So the best way is to find out the m1 and m2, that is the slope. So m1, just write in these in the form of y is equal to mx plus c, y is equal to mx plus c. This is m1, this is m2. So if they are parallel, m1 has to equal to m2, and if they are perpendicular, m1 into m2 equal to minus 1. We'll use these two theories. So m1 is this one, m2 is this one. Just equate and rearrange, you will get the first equation. And if they are perpendicular, m1 m2 equal to minus 1. So you get a1 a2 plus b1 b2 rearrange equal to 0. Next is find the equation of a line perpendicular to this line and passing through this. So this is your line. You can find out the m, and you know the line which is perpendicular to this m will be minus 1 by m. So we will find out the m of this using y is equal to mx plus c. So m is actually half. So minus 1 by half is nothing but minus 2. So this is the m of the second line. And since it is passing through these two, we'll use this y minus y1 is equal to m x minus x1. This is your required equation. Now we have to find out the distance of a point from a line. How we are going to get this? So let me show you. If we have this line and this is a point, what we are going to do is we'll join this and we'll use this triangle area to find out the distance, because we know that the area of triangle is half into base into altitude. So this will be our base. So this line will intersect the y-axis here, x-axis here. So we know that we can easily find out the point here. And this is already given. So this is given. So triangle area is half into base into altitude. Base we are going to find like this. Altitude is this. So this altitude is nothing but the distance. This is what we are going to find out. So ax plus by plus c, let us assume it to be a line. And this is d. We have to find out this d. Let us assume that this is our x1 y1 point. When this intersect with y-axis, just place x equal to 0, you will get y equal to minus c by b. And when you place this this intersect on the x-axis, you place just y equal to 0. So x will be minus c by a, and of course y will be 0. Now this happens now, and you have these points. So half into base into altitude is our area of this triangle PQR. The area of P, Q and R. Half into base into altitude. So we are interested in finding the altitude, but base we know. Base we can easily compute by the distance formula. So base can be easily found out by the distance formula. We'll use this distance formula. So the base can be found out like this. But one more thing, that the area of triangle is nothing but half into, you know the formula, half into x1, then x2, x3, and then y. All these combinations, as you are aware of that. So you can directly input these values because the values are known for a triangle. This triangle, these three coordinates are known. So this will be actually area of triangle. So let us take this expression, and now this is also known, half this QR, because distance formula. So QR and area, but you have to find out PM. Just place it here. So you will get the distance like this. Distance is ax1 plus by1 plus c by under root a square plus b square. And this is the point x1 y1. The distance of x1 y1 from ax plus by plus c is this. So you have to understand that just place the x1 y1 in this equation and you will get, and of course a and b you have to use. Distance between two parallel lines. How are you going to find out the distance between two parallel lines? Distance between two parallel lines means m. This m has to be equal. Means the slope of this line and this line has to be equal. Now what we are going to do is, we will try to find out this line where it intersect, and the distance of this point from this line will be our distance from these two lines, right? Or you can do differently. You can extend it. You can take this point, find out the point because it is intersecting the x-axis, and now you can find out this distance from this line. In both ways you can do. So this is first line, second line. We have found out the intersection point of this line with the x-axis. These are the points. And now we have to find out the distance. The distance can be easily computed like this. So when you find out the distance, this is actually C1. This C1 minus C2, that is the constant difference, the constants in the two equations, and this is under root 1 plus m square. So this is the actual thing which you have to remember for these two lines. And please see that ax plus by and ax plus by, these two are exactly similar. Only C1, C2, they are different. So let us take example. Find the distance of this point from this. Now you are aware that this is A, this is B, and this is your C. A, B, C. Now just place it. A, B, C, you are aware. Now you have to place 3 and minus 5 here. Ax1, by1. This is x1, this is y1. So x1, y1 need to be placed here. A, B, C you already know. So just use this formula. Under root a square plus b square. This will be 3 by 5. Now you have to find the distance between two parallel lines. See, 3x minus 4y is equivalent to 3x minus 4y. Only the difference is 7 and 5. So the direct formula c2 minus c1 by under root this square plus this square. So this is 2 by 5. So this was the third part of straight lines. We will be taking one more. Thank you so much. Take care of yourself.